Make sure y'all can see the desktop. Can y'all see the desktop? Yes, sir. Okay. Okay, good. All right. Now, as I said, the test is up for the related rates, and also we're going to go into antiderivatives, which is Unit 4. And with that, I will pull up the Geo Sketchpad. And I want to show you what you need to be thinking about. Remember, in derivatives, the biggest thing that you had to overcome was overcoming the limit. Okay? Same thing in the antiderivative. You need to be thinking about the limit. The limit as something goes to what? To 0. All right? Well, with the limit, with the derivative, you're going to be finding the slope of the line, the slope of the tangent line. With the antiderivative, you're going to be finding the area under the curve. Now, the best way to show you this is with my handy-dandy CD, because I can't draw it. So, where's the antiderivative? Should be in here. Probably under Raymond. Or Raymond, I'm sorry. Yep. Now, when you're trying to find the area under the curve, some of you may have seen this before. The old algebraic way is to take a rectangle and put it under the curve, just like so. Well, that sucks. You see why it sucks, because you got to overlap too much, then you got too much down here, and you got not enough. So what you do is this red line down here, you make this rectangle approach 0. And as it does that, it's going to, let me see if I can do this. 3, let's go to 4, there we go. As you do that, what happens to the rectangle? The rectangle gets smaller. And what happens to the overlap up here? It gets what? There we go. Now, that first red line, that first rectangle was right here. And look at it. It's starting to get inside the what? The curve. Now, you're talking about a width down here, half of a width of a what? Hair. Remember I told you to think of a hair. And if you think of a hair, if you see the first one that we saw was an overlap like that, and now you see it starting to what? Get so small that it's really irrelevant. Now that is basically the antiderivative. The antiderivative gives you the area under the curve. The derivative gives you the slope of the tangent line. Now, I'm not going to go through and show you Riemann, because basically Riemann says that you're going to take the width of each one of these rectangles and you're going to add it up. Okay? So, if you, okay, stop. Alright, let's go back to 3. How do I go back? Well, double click to change. There we go. Let's go back to 3. Alright, here's Riemann's theorem. I take the length right here and the width of this rectangle, and I say length times width. And it's not going to turn on. Oh, it's not even on. Take the length, or the length right here, which is your function. Let's call it f of x. Multiplied by the width. And then I'm going to take that and I'm going to add this function, this height, and multiply by the width. And then I'm going to take this height and multiply by the width. And I'm going to do what with those three? I'm going to add them together. Now, I'm not going to spend a lot of time with talking about Riemann, because Riemann it basically gives us the antiderivative, okay? But there's no point in going through it. It's kind of like going through the tables of trigonometry when all of you have what? Calculators, all right? So I'm not going to spend a lot of time with Riemann. And contrary to popular belief, I go against a lot of instructors that believe that you have to go through Riemann to understand the antiderivative. Well, I'm sorry, but I'm not going to insult your intelligence by saying that you don't understand. To find the area under the curve right here, you take these three rectangles and you add them up. I'm not going to sit here and tell you that. And I'm not going to spend a week telling you about Riemann when all you got to do is add up those. Well, you got to add up one here, one here, one here, one here, one here. So you're talking about 5 rectangles, and then you got to try to subtract this. All right, but that's all it is. You take this area plus this area plus this area plus this area plus this area, and you add them up. I'm not going to sit here and tell you to do that. And you can do that too, and get that, and we'll start to see. Just watch it. Take this one off a little bit. Take that out. Now, at this point, how many rectangles do you have? So you got to take, with Riemann, you got to take the height and the width, and you got to add it 24 times. That's Riemann. And the way that you show Riemann is with the sigma. Remember the sigma? I'll show it to you. Well, let's just go. I'll find it right quick for you. Here. And what did you say? 5 areas and distances. I'm going to show you Riemann. And then you can, you know how Chevy Chase and Jake Vacation, you know, there was a Grand Canyon and you looked at it 3 times and said, okay, let's go. I'm going to show you Riemann, and you look at it 3 times so you'll know what Riemann is, okay? So let me find it for you. Here's where they're showing you the area. And they're showing you the area here. There's part of Riemann right there. I'm just going to blow it up a little bit. Oops. Dang on, what was that? Dang on, Al Qaeda coming. That's getting close to it right there. They should give you a little blue box.
I think it said antiderivatives is in the last section of chapter 4.
Oh, it's in the last section of chapter 4. Maybe that's it. Hold on. Anybody know what page that is? 369? I don't know. Let's chapter 4 review. And usually they put that in Riemann. They put that in the. I don't see it. Well, we'll get to it eventually. I'm not going to spend a lot of time on it anyway. But Riemann tells us that if we take the summation of the function f of x times the base, which is length times width, and we add all of them up, n equals infinity. In other words, add all of them up, then we're going to get the area under the curve. And f of x, and you can put down here a to b, and a to b would be from 0 to that right there, and so f of x is right there times whatever this base is right here. And you're going to take this one, that's the first one. You're going to add the second one. You're going to add the third one. You're going to add the fourth one, fifth one, sixth one, seventh one, and the eighth. And you're going to add them all together. That's right in this here. Okay. Now, the antiderivative gives you the area under the curve. There's two types of antiderivatives. The first type of antiderivative is called a definite integral. An integral and antiderivative is kind of the same thing. Some teachers will call it the integral. Some teachers will call it the antiderivative. Tomato, doesn't matter, okay? It's the opposite of the derivative, okay? Now, the second type is the indefinite integral. The indefinite integral, this one you have parameters. I don't know why this thing is not writing correctly. The parameters for a definite integral is a to b. And I'll explain that here in just a minute. Indefinite integral has no parameters. Has no parameters, does not have an a to b, and basically you're just taking the antiderivative and that's it. Alright? The definite integral, you take the parameters and you plug into it. And you find your what? Area. Definite integrals, I like to tell students that it's for what? Drill. And what does drill do? Or, for those of you who don't know what drill means, make this something that's in wood. It's what? Practice. Repetition. Now, let's look at a derivative, antiderivative. And some of y'all have been through pre-calculus, you've seen antiderivatives, and you know that they are pretty simple because they're the opposite of a derivative. If I give you, find the f of x is equal to 2x squared plus 3. Then f prime of x is equal to what? Take the derivative. What is that? 4x. Okay? We'll give you another example. F of x is equal to 2x squared plus 7. What's the antiderivative? Well, these are the derivatives in the same. So that means there's infinite functions that can go with this antiderivative. And I'll do the antiderivative. Okay? Because you both see that we've got two different functions here, but they belong to the same family of derivatives. You see that? And that's very important that you understand that, because when we take the antiderivative, we have to add the plus c, because this one is different from what? That. Okay, so if you ever wondered why with antiderivatives you have to add plus c, it's because you're in a family. The family of 4x can give you this, or it can give you what? That. You don't know, and that's why with a definite integral or indefinite integral, you have to add the c. Now with a definite integral, the c is not there, because you don't know what it is. So, what is the antiderivative rule? The basic rule is, kind of like the power rule, if I give you 4x, f of x is equal to 4x dx. That means that I've taken the derivative of 4x, and I want to find the antiderivative. All right? The antiderivative of 4x is going to be 4x, and then what do I add? There's 1 right there. What do I add to it? I add another 1, and then on the bottom, I put 1 plus 1. 1. So now I get 4x to the second power over what? 2, which is equal to what? 2x squared plus what? C. Now the reason that it's 2x squared plus c is because we just said that this 4x represents two different, where really it's infinite. It could be 2x squared plus 4, 2x squared plus 6, 2x squared plus 5, 2x squared plus 1/2, 2x squared plus 3, 2x squared minus 2, 2x squared plus 100, 2x squared, infinite. So that's why you have to add the c, because you don't know what that one is. Okay? So you need to write that down. That's called the basic power rule of antiderivatives. So let's look and see where I am, see if I can find it in this book, which is hard to find in this book. Can't find anything in this book. The definite integral. They talk about rhyming for about 3 or 4 sections. So. Yeah, there's where we start getting into it right there. No, we're still doing rhyming. I think this is called the fundamental rule of calculus. I believe that's what it is. Yeah. And I'll pull that up. I don't know what the heck that is. But anyway, the sign for the antiderivative is the little squiggle sign. So if I tell you I want you to take the antiderivative of 3x squared dx, then you're going to pull that 3 out. You don't need 3, so pull it out. X squared dx. And that'll give you x to the what? Well, we've got to add 1 here. And then the fraction 2 plus 1 there. So our answer is 3 times, and what is the derivative of, what's the antiderivative of x squared? X to the third over 3 plus c. And what happens to the 3's? So your derivative of, the antiderivative of 3x squared is x cubed plus c. What are they talking about? You got to say it as one word. Whatever. Okay. Are y'all talking to me or y'all talking to each other? Okay, I think y'all talking to each other. All right. Just making sure y'all didn't have any questions since y'all don't have no daggum microphones. All right, let's try again. The antiderivative, 12x squared dx. Try that. These are indefinite intervals because they don't have any a or b. Now, in just a minute, we'll show you the difference between a definite interval and an indefinite interval. These are indefinite intervals. So, 12 comes out. That'll be x to the what? It's 2 plus 1. 3 over 3. And I don't need that after I do it. And 12 divided by 3. All right, let's try another. Now, what do you do in calculus when you have something like that? The first one. Huh? Quit. Good. Good. Glad I'm teaching y'all that. Still got that in there somewhere. What do you do with that negative 3? Bring it up. Rewrite it. Now, with derivatives and antiderivatives, you can break it up into 3 separate. And then like that if you want to. And what do you do with the constants? What do you always do with the constants? Pull them out. Now you don't have to, I'm just doing that to show you so you know that you can pull constants out. It'll help you in differential equations a whole lot. Now take the antiderivative on. So what's the antiderivative of x cubed? X to the fourth over what? 4. 3. X cubed over 3. Plus 4. What's that one? X to the first over what? 1. Let's see. And of course, 4's cancel. X to the fourth. 3's cancel. Well, that don't always happen. X to the third plus 4x. Capiche? Starting to see?
Is there supposed to be a plus sign in form of dx?
Supposed to be 4dx, I'm sorry. Well, the whole thing, this whole thing was supposed to be dx, so there. Now, definite integral. I'm going to show you what the definite integral is and tie in while we find the antiderivative or the integral. So we're going to do something real simple. We're going to do x squared. The antiderivative of x squared dx from 0 to 10. Now, first of all, I want you to graph it. Graph that function. You know what it looks like. It's a
So we use the same book as top here?
yeah, we use the same book up the top. So what you do is you take the derivative, and what we're doing is the x squared looks like this. And the reason I don't care about the other side is because I've only asked you from 0 to what? 0 to 10. So we're going to find the area from 0 to 10. We're going to find this area from 0 to 10. So that's going to be x to the third over 3, evaluated at 0 and 10. Now what that means is you're going to take 10, plug it in, and then you're going to subtract 0, plug in. So this means 10 raised to the third power over 3 minus 0 raised to the third power over 3. That's what that means. You always subtract because, well, think about it. If you want to find the area of something, you take the larger and you subtract the smaller. I'll do this one for you. That's 0. Ain't that something? I'll do that quick. Now, what's 10 to the third? 1,000, right? What's 1,000 divided by 3? 333.33. So the area under this curve is 333.33 square units. If it was inches, if it was miles, if it was feet, whatever. Now, where does this come into play? Well, a lot of application with this, especially if you want to find the acreage of a piece of property under a right-of-way of a highway, or going around a pond or a lake, and you have to figure the right-of-way acreage that comes into play when you're trying to find that acreage. Because not everything is a straight line in the real world. So you've got to have some application of finding the area under a curve and not have to do Ryman's theorem and spend 2 days doing all those lengths and heights and taking forever. So that's how the derivatives come into play. So a definite integral has parameters. An indefinite integral is to practice. Okay. Now that's also called evaluation. When you find the act of putting the 10 to the third over 3 minus 0 to the third over 3, that's called evaluation. You're actually evaluating the 0 to 10. And you always subtract it. So you might want to take a highlighter, take your handy dandy highlighter, and take a green highlighter. That means positive. That means that does not change. It's always going to be negative. Now, if this comes out to be a negative, then that changes this to what? Positive, and you have to realize that. But in just a regular application, this is going to be negative, or subtraction. All right, so let's try nerding. Antiderivative. I'm going to do x squared again. Dx. And this time, I want you to do it from -4 to 4. Let's throw a 3 in there too. Let's try that one. And I want you to try to do it another way. There's 2 ways to do this. Or you can just look at it and quit. You know, it looks like with all the stuff we can do, we still can't find a cure for function. Friend of mine just passed away this morning at 5 o'clock. Don't understand. Oh well. All right, what's the answer? Well, one way you can do it is this one. Anybody want to give me another way you can do it? Nobody has any earthly idea? No. Okay. That's not right. Do this. What's another way you can do it? Instead of going from -4 to 4, anybody got an idea? Well, what is a parabola? A parabola is, what's unique about a parabola? It's the same on the left side as it is on the right side, right? So to make this easier, I could do 2 times 0 to 4 of 3x squared dx. Why? Why would I do that? Because unless you like whips and chains, don't fool with that negative. That's why. All right? That, if you want to do that, that's good. Knock yourself out. But this is the same as that. Okay, I need some kind of acknowledgement. You understand? All right, so 3 times the derivative of x squared dx at 4 and -4. So that's going to be 3x cubed over 3 evaluated at -4 and 4, which is going to be 4 cubed minus -4 cubed, right? Mm-hmm. Which is going to be 4 cubed plus 4 cubed, which is going to be 128 square units. Here, we take the 2 times the 3, which is what? 6 times x cubed over 3, which is 2x cubed, evaluated at 0 and 4. I'll do 0 for you. 0 comes out to be 0. And then 4, 2 times 4 to the third is what? 128 square units. So, it might be beneficial for you to realize if something is what? Starts with an S. No, you're such a disappointment. Symmetrical, that's not right. There's no N in there. Symmetra. Thank you. Thank you for the 2% input. Thank you. Symmetrical. It might behoove you to maybe graph it if you don't know to see if it's symmetrical, because it'll save you a whole lot of time and it'll save you a whole lot of punishment having to deal with that negative, because we haven't even seen any challenging problems yet throwing in the negatives. These are all on a scale from 1 to 10, with 10 being difficult. These are all do you mind? These are all halves, okay? We haven't done any difficult ones yet. All right? So, let's look at another, let's look and see if they have any in your book that we can derive off of. Let's make sure the Tandy twins are okay. Okay, I don't know, they still get a life in the sad case. Okay, they're all right. Let's see if we can find something in this book that I can operate very well. Okay, they already do an antiderivative, but they haven't even. How can they do the antiderivative cosine if we haven't even done? I don't see the derivative of. The antiderivative of e to the x is e to the x. That's easy. There's one that we've done. If you want. All right, here's a couple. We'll blow it up for you. These are definite intervals. All right, we did one like this one. So I want you to try 21. Try 21. So what does hombre mean? Is that what it means? Geraldo Rivera was on the news this morning and said he was offended. Huh? I know he always worries about himself being politically correct. He really stays up at night worried about it. Not like I do. Huh? What's your origin? Where's your origin? Venezuela. That's a pretty rough part of the country. Isn't that Hugo Chavez? It was until he died of mysterious cancer by the pants. That's what they say. CIA. I wonder. I'm gonna shut up, Hubert. I'm gonna show my conspiracy theory. I'm gonna shut up. I'm just gonna say I don't believe that they don't have a cure for cancer. Let me just say that. Exactly. I think the media has too much control over things, and I think the Democratic Party has too much control over things, and I think the pharmaceutical companies have too much control over things. And I'll shut up with that. Just like I also think that the three major car companies, Chevy, Ford, and whatever Chrysler is now, I really don't think they want engines to improve, like the ceramic engine and like engines that can run off of water or hydrogen. I don't think they want that to be successful. Okay, no input. All right.
I mean, as long as they're oil to sell.
Huh?
As long as they're oil to sell for the oil industry to make money.
Yeah, but we got to save the lizards. We got to save the lizard. There's a lizard in Oklahoma that we can't drill oil because there's a lizard that lives out there. That's no joke. I'm not making that up. You think Russia cares about the lizards in Russia? You think China cares about the lizards in China? That would be hell to the no. But we, in America, we worry about our lizards. And we have to buy oil from other countries because we can't kill the caribou in BFE, Alaska, where there's tons of oil, but we can't because we got to save the caribou. Sorry, that makes no sense whatsoever. Okay, this guy, I did this just to depression. What's the first thing you should do with this guy? You should rewrite it and pull out all of the what? Constant. All of the constants, because that's the first thing that's going to bog you down. So, take our handy dandy snipping tool. We'll pull this guy out. Save it. And go to the whiteboard. Now there's a smart way to do this one and a not so smart way to do it. And the smart way to do it is pull out the constants first. So I'm just going to put the 2 and the 0 there, and I'm going to pull the 4/5 out, and that's going to leave me the t to the third dt minus 3/4 0 to 2 t squared dt plus 2/5 antiderivative from 0 to 2 of t dt. Now, it may be basic for some of you, this half, but I'm not teaching to the people that know it. I'm teaching to the people that's never seen it. Okay? This is the way you would do it if you get an anxiety attack when you see a problem. You need to lessen the anxiety. You pull this stuff out, and now you're left with a simple derivative. So that would be 4/5. And I'm going to put a bracket here. And what is t to the third antiderivative? T to the 4th over 4. And I'm going to put 0 to minus 3/4 bracket t to the third over 3 evaluated at 0 to 2 plus 2/5 bracket t to the second over 2 evaluated at 0 to 2. Now, do you have to do the 0s and 2s at each one, or can you just wait at the end? You can wait at the very end. That doesn't matter. You can pull the 0 to 2 out here and say 0 to 2 antiderivative, and then pull out, okay, whatever, and then make a bracket, and then do, antiderivative of 4/5 antiderivative t to the third minus 3/4 antiderivative t squared plus 2/5 antiderivative t, close bracket. You can do that if you want. So what happens here? 4's go out, you're left with t to the 4th over 5 minus What? What'd you say?
Cancel. I was just.
Oh, okay. Can I be in charge for a while? All right, thank you. The 3's cancel, and that'll leave you with t to the third over 4. I don't know why this keeps popping up. Plus, what happens here? T squared over 5. And all that is evaluated at 0 and what? Well, I'll do the 0 for you. 0 gives 0. So you don't have to do the 0. So all you're left with is 2 to the 4th over 5 minus 2 to the 3rd over 4 plus 2 to the 2nd over 5. And just so you'll know what your answer is, 2 to the 4th is 16 over 5, right? Minus 8 over 4 plus 4 over 5. And what's the common denominator of 5, 4, and 5? 20. So 5 will go into 24 times. 4 times 16 is what? 64? 4 will go into 25 times 8 is 40. 5 will go into 24 times 16. Y'all check me. 64 minus 40 is 24 plus 16 is 40 over 20, which is 2. Y'all get 2? And y'all feel good about yourself. Okay. Let's try nerding. Huh? Well, you don't have to worry about, with definite integrals, you don't have to worry about the C because you're working with the actual derivative. And their thinking is the constant that's out there, that could be out there, the plus 1, the plus 2, the plus 3, is going to be minute compared to the area that you're finding. So that's why they don't worry about the C there. Okay, let's try nerding. We haven't covered the signs yet, so I got to find that in the book. I don't know. Derivative sign is negative cosine, but we're not going to be antiderivative. We're not going to worry about those right now. Let's do one with a radical in it. That'll discourage you. Let's do 29. What's the first thing you should do? Rewrite it. Why? And then maybe distribute. Because we don't know how to do the chain rule or the product rule yet. We haven't went over that, so you can't. You're going to have to do something to combine them. So, antiderivative from 1 to 4 of 2 plus x squared over x to the 1/2 dx. The antiderivative from 1 to 4 of 2 plus x squared times x to the what? Negative 1/2. And then distribute antiderivative of 2x to the negative 1/2 plus, well, what's 4 halves minus 1/2? 3 halves, you would thank you, class. So now take the derivative, antiderivative of that. Now you might want to write everything out because you got fractions and you need to write everything out. So 2 brackets, and what's the antiderivative of x to the negative 1/2? X to the negative 1/2 plus 2 halves over negative 1/2 plus 2 halves plus x to the 3 halves plus 2 halves over 3 halves plus 2 halves, evaluated at 1/4. So what's negative 1/2 plus 2 halves? Well, x to the 1/2 over 1/2 plus, what's 3 halves plus 1/2? Oh, I'm sorry, 2 halves. All right. 5 halves over 5 halves, evaluated at 1/4. When you divide by a fraction, you multiply by what? Four x to the 1/2 plus 2/5 x to the 5 halves, evaluated at 1/4. Exponent over index, so that's going to be the square root of x to the 5th. which basically is x times square root of x, but we're not going to do that. So 4 square root of 4 plus 2/5 square root of 4 to the 5th brackets minus 4 square root of 1 plus 2/5 square root of 1 to the 5th. So what's 4 times 2? Okay. Plus 2/5 times the square root of 4 is what? 2, and 2 to the 5th power is 32. Minus 4 times square root of 1 is 4, plus 2/5 times square root of 1, if any root of 1 is 1. And that's going to be 64/5. 40 plus 64 is 104 over 5. Somebody check my math. Minus, and this will be 20 over 5, 22 over 5. 104 minus 22, 104 minus 20 is 94, so it's going to be 92 over 5. Somebody tell me if that's what y'all got. I'm waiting. What'd you get?
I put it on Dr.
Well, they don't tell me anything. Might be. Yeah, because 104 minus 20 is 82. I'm sorry. 82 over 5. Is that what you got? I said 104 minus 20 is 94. That's not right. So, oh, I forgot to ask y'all. Where's the calculus? Let's see. Where is the calculus? I did the calculus and erased it. How much of the problem is calculus? Very little. How much is basic math and algebra? 80%. So if you're going to suck at calculus, that's because you suck at what? Algebra and basic math. How do you feel? Well, the whole point of me showing you this is so you'd be confused going to taking the test with new material. That was the whole reason. But I have to do something because that one person will complain, well, he didn't do anything today in math. So I have to do something. So I'm not going to put any homework up right now. We will continue antiderivatives when y'all come back. When? What's today? Tuesday? When y'all come back Tuesday. So get the test done over the weekend, get the homework done over the weekend, or whenever the related rates homework finished. And I will see y'all Tuesday, okay? Y'all got that? Y'all got that? Faith and Mr. Selee? Yes, yeah. Okay, y'all have a good weekend.